Okay, so going into the lab for vectors, week 1 in AP Physics. Uh, there's this whole little intro, you can read that yourself. And so going into part 1 of the lab, and calculate the total distance that Mr. McNeil travels on his trip home. Simply add all the distances together to get the total distance. There, of course, isn't much to this, just adding together all the distances that Google has listed. So for the total, Google has listed 37.3 miles. And adding together the all of the individual components of this, you should get about, or I got 37.2108 miles, which is just more accurately accounting for the distances that they list in feet, because, you know, they're that short. So going into part 2, calculate the uncertainty in this measurement. We are adding like values, so you should be adding the plus or minus uncertainty of each measurement before calculating the percent uncertainty. Here is the link to that bit. Okay, so we're going to, for each of the measurements except for 2 which are in feet, the measurements don't go beyond 1 decimal place in miles, so the percent uncertainty could be said to be 20% of the least count, being 0.1, which would be plus or minus 0.02 miles. And so then we can basically add that to itself, or 16 times or multiplied by 16. And then that is the uncertainty for the total measurement in miles, except for the feet measurements, which is 0.3 or plus or minus 0.32 miles. Then we have to add the uncertainty for the measurements in feet, which would be plus or minus 20% of 1 point, so plus or minus 0.2 for these 2 measurements, which add up to 571 feet. So it would just be plus or minus 0.4 over 571, and then 0.32 over 37.2 miles. I'm just using Google's measurement minus about what the feet can be converted to, which is about 0.1 miles, so 37.2 rather than 37.3. Then converting the uncertainty measurement from feet to miles, it is an extremely small number, and it comes out to 0.00007. So then we just add this to our current uncertainty. And then add the feet to the miles, which, you know, comes out to 37.3 about. So then we just calculate this out for the percent uncertainty. 3207. 37.3. And this comes out to, and then we multiply it by 100 to get the percent, and this comes out to 0.86%. And that's the percent uncertainty for step 2. Okay, so going into part 3. Part 3 is calculate the average speed, and then it basically asks us to do a bunch of conversions. So for the initial average speed, I'm going to go for miles per minute, and the total time is 73 minutes, and the total distance is 37.3 miles, so you just divide that, and it comes out to 0.51 miles per minute. Then this, if you multiply it by 60, you'll get miles per hour, which will be 30.66 miles per hour. And then to convert it to meters per second, you just put it through the converter and it comes out to about meters per minute, it comes out to about 13.71 meters per minute, which will then come out to, hold on, 0.23 meters per second. And then the question goes on to ask, do you think that he traveled the speed the entire time? And what about 85 miles per hour on Highway 76? What would this mean for about the average speed? Of course, he didn't travel this speed the entire time. He traveled faster on the highways and slower on the streets. And it averaged out to 30.6 miles per hour. So that's what an average is. And I also would highly doubt that he'd be going 85 miles per hour on Highway 76, especially in commuters' traffic. So going into step 4, calculate the uncertainty in the average speed. Because the average speed is a product, when calculating the total uncertainty of average speed, add the percent uncertainty found in step 2, plus the time percent uncertainty in the time measurement. So this is pretty simple. We're basically taking the uncertainty from step 2, which is, the percent uncertainty. Right. Yeah, we're taking the percent uncertainty from step 2, which is 0.86%. We're adding that to the uncertainty, or the percent uncertainty of the time measurement, which would be, the smallest unit was minutes, so this would be plus or minus 0.02 minutes. And you divide that over the total time, which was 73, and you come up with and you come up with 0.00027 percent. So then you just add this to the 0.86 from earlier. And it's you're going to get a total percent uncertainty of 0.860. I'll go ahead and go to 0.3%. So not much difference from the time measurement, since it went to as low as minutes. So then moving on to step 5, which is print off the larger map with or without writing directions. Draw a right triangle on the map with hypotenuse as the length between the school and his home, and one of the two remaining sides entirely on the y-axis, north-south, and the last side on the east-west axis. So I've already done this on this map. I don't know if you can see. This is pretty easy. You just align this as well as you can by measuring out the distance on top, bottom, and to the point. Do the same on each side. Draw the lines, connect the points, and then you've drawn the right triangle. So then we move on to step 6. Measure the distance in the x and y direction. Using the key in the lower left-hand corner, calculate the uncertainty in the x and y direction. Unfortunately, the key is lost and never to be found, and even on the site, the key actually just showed a conversion between kilometers and miles, and I'm completely wrong. But going, so on 6, in order to find the conversion on this, I took this measurement, or this distance, which I know from the directions to be 5 miles, and measured it out. Measuring it out, it came out to 5/8 of an inch, and it's 5 miles, so that means that on this size of the map, 1/8 of an inch is the equivalent to 1 mile in real life. So then taking that, I measured the y and x axes, and going in the east direction, I came up with 1 1/8 inches, and then going in the south direction, I came up with 3 1/2 inches. This converts to 9 miles on the x-axis and 28 miles on the y-axis. And this has very low uncertainty because, and I'll state that in a little bit, because 1/8 of an inch is 0.625 inches, and then plus or minus 20% of 0.001 is of course 0.0002, and then when you plug that into the uncertainty equation, for each one it's plus or minus 0.0016 miles, which comes out to, on the x-axis, 0.00017%, and on the y-axis, 0.0005%. Okay, and then we can go on. So 7 is very much so like 4, but first we have to calculate the average speed. So it's sort of like a combination of 3 and 4. So first, I'll calculate our average, or McNeil's average speed in the south direction, or on the y-axis. This is 28 miles, so it's in an hour and a half, so it's going to be 28 over, it's 73 minutes. This comes out to 0.38 miles per minute, or 23.01 miles per hour. Then to find the uncertainty in this, it's going to be the uncertainty from problem 6 and the time from the time uncertainty from problem 4. So in 6, for the y-axis, we came up with a percent uncertainty of 0.00005%, and then we just add that to 0.00027%, and get another extraordinarily low number. Oops. Point 0.00032%. Okay. And that's for the y-axis. For the x-axis, it's going to be 9 over 73, which is 0.12 miles per minute. Which is 7.39, or rather 7.4 miles per hour. And then we do the same with the uncertainty. This time it's 0.00017% plus 0.00027%, and we come up with 0.00044%. And that is the lab for Chapter 1. I mean, not Chapter 1, Chapter 2, which is Vectors, Week 1, AP Physics. Woo.